Audio Jungle. Audio Jungle.
Everyone, myself Naren Singh Maurya. So guys, today we'll solve GATE 2012 rocket propulsion problem. So here we have problem. A rocket motor has combustion chamber temperature of 2600 Kelvin and the product have molecular weight of 25 gram per mole and ratio of specific heat, okay, 1.2. The universal gas constant at 314 joule per kg mole Kelvin. The value of theoretical velocity, basically C star is the theoretical velocity in meter per second. All right, so I will write the given data first. That combustion chamber temperature, it is nothing but Tc, and you know that combustion chamber temperature is what always total temperature. So this is nothing but total temperature, and that value is nothing but 2600 Kelvin. All right. Propellant had molecular weight. So molecular weight they have given, it is nothing but you just say m 25 gram per mole, okay, and ratio of specific heat means gamma is nothing but 1.2. Universal gas constant, which is Ru, is nothing but 8314 joule per kg mole Kelvin. The value of theoretical C star in meter per second. Okay, that theoretical velocity they are asking. So here the value of theoretical C star. All right. So C star they are asking, and here the C star value, which is nothing but characteristics value. Characteristics velocity. Okay. What is the C star? We know that formula. We need to remember that C star formula. C star is the characteristics velocity. In previous problems I had solved, okay, if you remember, and that many formula it is given, but which one is the reliable formula for this problem, that we should know, because uh, see, like chamber pressure they have not given, and throat area they have not given, so we cannot use, because we have, if I will write all the formula. So as we know, C star, which is characteristics velocity, that formula is what? Chamber pressure, okay, into throat area, all right, divide by mass flow rate of the propellant. This is the one formula. Another formula we have, that is ISP G divided by CF, and another one more formula we have, that is V effective divided by CF. What is the CF? CF is the thrust coefficient. Thrust coefficient. So among all the formula, if you check, three formula I have written for the characteristics velocity C star. So chamber pressure they have not given, ISP they have not given, so we'll go with this formula, V effective by CF. So we should know the relation between V effective, CF, and that C star. So we got now that relation. We can write here C star is V effective divided by CF. Now we should know what is the CF. CF is the thrust coefficient. So I must write the formula. Okay, thrust formula. What is the thrust? Here okay, this is the exit velocity. Mass flow rate of the propellant is m dot p. All right, and if you go for the pressure thrust, so exit pressure will be pe and atmospheric pressure is pa. So I must write the formula m dot p ve exit area ae p minus pa. So I must say that information they have not given for the exit pressure and pa. So I can consider it is optimally expanded. I can take this, okay, optimally expanded case, because that information they had not given. So this is PE is equal to PA. Now what is the thrust? Now we have m dot P into VE. Alright, this will be the formula. And if it is optimally expanded, so that pressure thrust will be cancelled out. You will have only momentum thrust. Now we can non-dimensionalize this. This is the thrust. So thrust is nothing but one force. So pressure into area will be the force. So it will be non-dimensionalized. So what is the pressure? EC into area is throat area. I can write this. Okay. So this value will be CF, called thrust coefficient. And non-dimensionalized mass flow rate m dot p divided by Cc into ATH. This is the non-dimensional. Uh, if you write this value, this is the remark I must say. Okay, this is the remark. You need to remember, because this derivation already I had given, so I'm not going to write this. Okay, this value if you write here, so m dot divided by PCATH, this value will be 1 by root of T naught or TC in root gamma by R, okay, 2 upon gamma plus 1 divided by this derivation I had given in my previous lectures. If you go through the solution, then somewhere you may get, okay. Or if you say, then I will write the non-dimensional mass flow rate formula, so it will be more clear. Okay, wait, I will mention here how it comes. It is called non-dimensional mass flow rate. What is the non-dimensional mass flow rate? It is nothing but m dot, here we, this is the mass flow rate of propellants, m dot p divided by throat area ATH, total temperature divided by total pressure, because it is a like a combustion chamber. So total temperature and total pressure you have to write P naught R by Y. This is the derived formula. Okay, It is derived in my previous slides. If you go through the previous solution, so somewhere you may get, and this value will be 2 upon, for the maximum mass flow rate, Mach number will be 1, so it will be 2 upon gamma plus 1 whole power gamma plus 1 divided by gamma minus 1 and then root. If you solve this, then you may get this mass flow rate divided by PCATH. If you write, then automatically this step you may get. So this is the formula. Okay, this is the derived formula. You have to go through it. It's a simple one only. Now, so you got the formula here. What is the formula? C star, okay, is nothing but V effective by CF. All right. And here if you check, what is the CF? We got CF is equal to, check, CF is equal to V effective, okay, from the, see, m dot p divided by PCATH, this value is nothing but 1 upon root 2, so here it is VE, so we can write this VE upon root T naught, VE upon root T naught, rest as it is. What is the rest? Gamma upon R 2 upon gamma plus 1 whole power gamma plus 1 divided by gamma minus. Yes or no? We can write this is the root. Check. Yeah. So what is the C star? It is V effective or exit divided by CF. So what is the value here? It is root of T naught divided by gamma R 2 upon gamma plus 1 whole power gamma plus 1 divided by gamma minus. Okay. And it is in root. All right. Or else you can write this whole, you can write. Well, all right. Hope you all understood this. Okay. Now we'll write all the data here. Now, because universal gas constant they have given and mass of the molecules they have given, so R we can calculate. It is nothing but RU divided by M. What is the RU they have given to us? RU they have given 8314. 8314 divided by M. What I feel here, there is missing of data because they have not given the condition optimally expanded. So I have assumed that, no? Then only pressure thrust will be removed and then only you will go through this way. Okay. So few things I think it is missed. So you need to assume that. That's all. Let me calculate. 8314 divided by 25. It's 332.56 joule per kg Kelvin. Gamma they have given to us 1.2. T naught means TC, combustion chamber temperature, it is given to us how much? It is 2600. 26. All data we have to keep here. The next slide I will write this C star Okay, we'll write all the value. It is 2600, 1.2 divide by, it is 332, 2.56, all right, into 2 upon gamma plus 1, 1.2 plus 1 whole power, 1.2 plus 1 divided by 1.2. Okay, let me calculate this. So first I'll start from 2 upon 1 plus gamma. Gamma plus 1 means 2.2 to whole power we have 2.2 divided by 0.2, it's 0.35 into uh, 1.2 divided by 332.56. This is the value. 2600 divided by this value, will take the root. It is 1433.80 meter per second. This is the answer. All right. So this is the fill in the blank or what? Fill in the blank. So 1433.80 meter per second it is given. Only this data you have to. Hope you understood this. This formula you must remember. That's the reason remark I had given. Okay. So, but already I had derived, so I thought not to derive here. So I have given that formula directly. Non-dimensional mass flow rate formula. It is very useful formula, and many times I think in compressible aerodynamics you have used that. So in gas dynamics or compressible aerodynamics, so you from the non-dimensional mass flow rate you just get what is the m dot p divided by pcath, and then if you know c star characteristics velocity, and then use this concept, and finally we'll get this. All right, we'll go for next problem. So this is the another problem again, GATE 2012. Okay, a rocket propulsion. So a solid propellant of density, it is given solid propellant of density 1800 kg per meter cube, all right, has a burning rate law. Okay, R is equal to this value they have given, millimeter per second, where P is pressure in pascals. It is used in a rocket motor with a tubular grain with an initial burning area of 0.314 meter square. The characteristics velocity is 1450 meter per second. What should be the nozzle throat diameter to achieve an equilibrium chamber pressure of 50 bar at the end of ignition transient? Okay. So first of all, what is the burning uh, rate law? Burning rate law. So it is nothing but R is equal to A e to power n. What is the R? Okay. Burning rate. What is A? Burning constant. Okay. P, right? Combustion chamber pressure N is pressure index. Yes or no? So first of all, we should know what is the burning rate law. All right, we need to remember this because it is a very important formula, and in gate they had asked, okay, they had asked question based on it. So we should remember this, okay, formula always. Now, so will you how to use this formula, that is very important, okay. We have to remember the unit first, okay, because burn rate unit is what, millimeter per second it is given to us. So now we'll do one thing, we'll write all the data, then I will tell you like how to use this formula. So another data they have given, propellant density, rho p for propellant density they have given 1800 kg per meter cube, okay. P is pressure in pascals, okay, whatever the pressure it is given, it is in pascal, okay, it is given, it is clearly mentioned here. It is used in rocket motor with a tubular grain with an initial burning area, okay. So that burning area is, they have given, so AR burning area, which is nothing but 0.314 meter square, okay. Characteristics velocity they have given to us, which is nothing but C star, how much, it is 1450 meter per second, okay. And chamber pressure PC they have given to us, how much, it is given 50 bar, 50 bar. Now they are asking what is the nozzle throat diameter. All right, so check. Nozzle is here, okay. And for this we have a propellant. So all the story like burning rate and all, it is given for the propellant. All right. Now this propellant is density is rho p, okay. Area, initial area of the burning, it is given. Now if you check the mass flow rate of the propellant, if I say what is the mass flow rate of the propellant, so it is nothing but, mass flow rate is nothing but what, generally rho area into velocity. This is the formula, right? Rho a v. Huh? You check the unit, kg per second. Rho density is nothing but mass per unit volume, so kg per meter cube, area meter square, velocity is meter per second. If you solve this, what you may get, kg per second. So instead of, see, rho of the propellant they have given, area of the propellant, initial area they have given to us ap, instead of velocity it is nothing but burning rate, because burning rate unit is also millimeter per second. So the thing is, you need to convert into meter per second, that's all. Unit you need to convert in meter per second, rest everything is fine. That's the reason I have written the unit also, so that you can understand. So unit should be kg per second. Rho av, v is the velocity and general unit of velocity meter per second. Burning rate unit also millimeter per second, means meter per second you can convert in meter per second. So hope you understood that mass flow rate m dot p you can get from here. Okay, why I'm writing this formula? Because C star, if you check what is the C star, that characteristics velocity, that C star, previous problem I had written the formula. Previous problem, what was the C star I had written? If you remember, it was PC. Okay, that is the chamber pressure into throat area divided by m dot p. So C star they have given, PC they have given, m dot p. If you calculate from here, then ATH means throat area you can get, and if you get throat area, then this throat diameter you can calculate. What is the throat diameter? Pi by 4 throat diameter is square. So anyhow, if you get this throat area, then automatically your problem will be solved. Yes or no? So I must write here ATH is equal to pi by 4 DTH square is equal to, it is nothing but C star into m dot p, okay, divide by PC. Hope you understood. This will be the ATH, and from here you can get what is the DTH. What is the DTH? DTH is nothing but 4 times C star m dot p chamber pressure into pi, okay, and then you take the root of it. This will be the throat diameter. So C star is given, PC is given, only m dot p is what unknown. Now m dot p also you got that formula, and all the data it is given. So I will calculate first m dot p. It is density of propellant, area of propellant, okay, area of propellant in the sense initial burning area it is given for the propellant, and then R. We'll write the data here. What is the rho for the propellant? It is nothing but, I think 1800, 1800, yes, 1800. What is the area of the propellant it is given? Initial burning area, it is nothing but 0.314 here, 0.314. Now we'll go for the R. What is the R? It is given how much? What is the A? A is a constant, and here A is the 6.5 into 10 power minus 3. We'll write this. Okay. So here this is nothing but 6.65 into 10 power minus 3. This is nothing but A. P to power n. What is P? What is the P? P is nothing but, check, it is given 50 bar. Alright. So you need to write 50 into, what is the power n? 8pn. N is nothing but 0.45. So 0.45. Alright. And it is millimeter per second. R is millimeter per second. Check. Millimeters, so you need to convert into meter per second. So what you will do, you will multiply by 10 to the power minus. Okay. We'll calculate this. How much? Wait. 50 to power 0.45 into 6.65 10 to the power minus 3. Okay. Better I will write 6 because 10 to the power minus 3 that side and 10 to the power minus 3 that side, into 6 into, sorry, 0.314 into 1800. So I'm getting here check this value that pressure they have given in Pascal, okay, here, but this value is what, 50 bar. So need to correct this. This is nothing but 50 bar, so I must write this part, okay. Because pressure must be in Pascal, so I have to write, wait, 50 bar means 50 10 to the power 5, okay. So m dot p, again I will write so let me calculate this value. See, sometimes in few books they will be given like pressure should be in this formula, pressure should be in kilopascal. That is also okay, because if you write kilopascal, then automatically your unit will be converted, okay, millimeter meter per second. That millimeter will be meter per second, that case. Anyway, we'll write this. So how much it is? 50 10 to the power 5, okay, to power is 0.45, all right, into 6.65, 10 to the power minus 3 into 10 to the power minus 3, that is 10 to the power 6 into 1800, okay, 1800 into 0.314. So it is, I'm getting here 3 point is 3.8865. What is the unit now? Kg per second. All right, as I told you, now you have to use this formula DTH, that is the throat diameter. What is the formula you have written? 4c star, 4c star m dot p, okay, m dot p divided by pc, chamber pressure, into pi, and it is in root. So we'll write all the data. 4 into, what is the c star? It is 1450, 1450 into m dot p. Just now you have calculated 3.8865. Chamber pressure is what, 50 bar, so 10 to the power 5 into 5, and take in root. We'll calculate this DTH. Wait. So into 41450, 3.88 is already there, divide by 50 10 to the power 5, divide by, okay, take root of it, we'll get 0.03788 meter square. Yes or no? This is the answer. Check. It is given in, sorry, not meter square. Why I have written meter? It is diameter, okay. So diameter, definitely it will be in meter. It is not area anyway. So, but they have given in millimeter. So we'll convert this to multiply by 1000. So I'm getting here 37.88 millimeter. Check the unit answer, 37.88. So you can take this as 38. What is the correct answer? 38 mm. Hope you understood this. So your answer is, all right. Answer is B. Hope you understood. Simple only. We just use the formula. That's all. Nothing is there, right? The burning rate formula you need to remember. Okay. This is the next problem here. So again, it is GATE 2012. That time they had asked many problems from rocket propulsion. So here we have a bipropellant liquid rocket motor operates at a chamber pressure of 40 bar with a nozzle throat diameter they have given 50 mm. The characteristics velocity 1540 meter per second. Fuel oxidizer ratio of the propellant is 1.8 and fuel density 900 kg per meter cube. What should be the minimum fuel tank volume for a burn time of 8 minutes? They are asking what should be the minimum fuel tank volume. Minimum fuel tank volume they are asking. All right. So first we'll write given data. Okay. They have given chamber pressure PC, that is P naught, how much? Total pressure 40 bar. Nozzle throat diameter they have given DTH or small d, no problem. How much? 50 mm. Characteristics velocity they have given C star 1540 meter per second. Fuel oxidizer ratio FYO. It means mass flow rate of fuel divided by mass flow rate of oxidizer, OX I will write. It is given 1.8. The fuel density they have given rho of F, means fuel. You cannot write propellant because we have a bipropellant liquid rocket. Okay, so we'll have a fuel and oxidizer in separate tank. Yes or no? So fuel density they have given 900 kg per meter cube. Like in the previous problem, it was given density of propellant because it was solid propellant rocket system. Yeah? But here we have a bipropellant liquid rocket system. So whatever the density it is given, they can give like density of fuel and density of oxidizers separately also they can give. So because why they have given density of fuel? Because they are asking volume of the fuel tank. Calculate what we need to calculate. Okay, calculate volume of fuel tank means V is the volume of fuel. Volume of fuel tank, check, is nothing but volume of fuel. Volume of fuel. So that for that reason only they have given density of fuel. Hope you understood. Okay, burn time of the 8 minutes they have given. I mean, up to what time that fuel will be burned in combustion chamber. So that time they have given to us burning time, no? 8 minutes. Anyway, we'll proceed this problem. It's simple again. We need to go with the concept only. Anyway, so like here they have given a diameter, so we can calculate area of the throat is nothing but 5 by 4 into PTH square. Yes or no? Okay, we'll proceed this. So what will be the system here? Now We have a tank here, okay. Two separate tank we have. We just say this is nothing but fuel tank and this is the oxidizer, okay. Oxidizer. Yeah. Or oxygen you can say simply. Now, so what is the throat? This is the throat here. So what is the throat area? It is nothing but pi by 4 dth square. How much? Pi by 4 dth is nothing but 50 mm. How much will get? Wait, let me calculate. Here I am getting 1.96 10 to the power minus 3 meter. This is the area. Why I have calculated area? Very simple. Check. Because we are going to calculate the fuel tank, so you just say this is the fuel. So for the density of the fuel is nothing but rho f, and obviously volume of the fuel tank is nothing but vf. So for this, mass flow rate will be m dot ox oxidizer and the mass flow rate of the this is what fuel, so m dot f. See, if I say what is the mass of the propellant, so propellant means what? Oxidizer plus fuel both, m dot f plus m dot oxidizer. You need to remember this. Why I have written this? Because they have given characteristics velocity check C star they have given to us. So if you write the formula for C star, I told you this characteristics velocity formula is very important. Many times question they have asked. Previous problem also you have seen related to characteristics velocity. PC ATS divided by m dot p. So everything you have now, you can calculate m dot p. What is the m dot p? It is PC ATS divided by C star. What is the PC? PC is nothing but 40 bar. I must write 40 bar means 14 to 10 power 5. ATH 1.96 into 10 power minus 3 divided by C star. What is the C star? 1540. Okay. M dot P. We'll calculate 40 10 to power 5 into 1.96 10 to power minus 3 divide by 1540. It is I'm getting here 5.09 kg per second. Okay. Why I have calculated m dot p? Because anyhow I have to reach to this m dot f. Because what will be the m dot f? What is the density mass flow rate per unit? Mass per unit volume. Yes or no? Density is nothing but mass per unit volume means m dot f by v of f. So if you know m dot f, then you can calculate v f, volume of the fuel tank. All right. So we'll proceed this. So automatically you will understand one by one. If you will do that, then it will be very clear to you. Okay. Anyway, m dot p we got. We know that m dot p is equal to m dot f, m dot f plus m dot ox means oxidizer. One thing. Second thing, that ratio they have given to us, m dot f by m dot x they have given to us. M dot f divided by m dot ox, that ratio oxidizer, that ratio they have given 1.8. So these two equation we have. We'll solve this two equation. We'll calculate m dot f. Means we have to replace m dot x. Okay. Again I will write here. And m dot f divided by how much they have given to us? 1.8. I need to calculate m dot f, so I will replace m dot x. Ox means oxidizer. So it is nothing but, we'll place here. So it will be m dot p, m dot f already there, plus m dot ox is nothing but, yes or no? What is this value? It is nothing but 2.8 m dot f divided by 1.8. If you solve it, so what will be the m dot f? M dot f will be 1.8 m dot p divided by 2.8. 1.8. What is the m dot p? Just now you have calculated 5.09. 5.09, 2.8. How much you may get? Wait. 1.8 into 5.09 divide by 2.8. I'm getting 3.27 kg per second. All right. So m dot f kg per second you got, but what is the volume? Volume is a meter cube. Density is kg per meter cube. So this kg per second, that unit should be kg. Means you need to calculate mass, not mass flow rate. For that reason, they have given up to what time it is burned. It is burned 8 minutes. We'll calculate mass now. So what is the mass flow rate? M dot f is equal to mass, not dot. Dot need to remove. Is not dot now. Okay. So mass, I will write mass divided by burn time. That is called mass flow rate. M dot. That's the meaning of m dot f. Mass we need to write m f. Not, this is m dot f. Okay. Remember, this is only mf by burning time. Hope you understood this. Again, I will write. So mass flow rate of fuel is nothing but mass of the fuel divided by burning time. So what is the mass of fuel? It is nothing but mass flow rate of fuel into burning time. What is the mass flow rate of fuel? 3.27 kg per second. What is the burning time? 8 minutes. That minutes should be converted into second. I will write 8 minutes. It will be converted into second. So multiplied by 60. Okay, and unit will be second here. So check this, second and second cancel out. Sorry. This is not dot, it's only mf, mass, not mass for it. I will calculate this. How much? 3.27 into 8 into 60. I'm getting 1569. I'm getting 1569.6. 1569.6 easy. Alright. Now, what is the volume of fuel tank? Okay. So it is nothing but Vf. What is this value? This is nothing but mass of fuel divided by density of fuel, means mf divided by rho f. So what is the Vf? That is the mass of volume of fuel. Mf. What is the mf? 1569.6 divided by density of fuel. It is given how much? It is 900. Divided by 900. I'm getting 1.744. 1.744 unit is meter cube. Check 1.744. Any option is there? 1.744 means you can take. This is your correct answer. 1.75 meter cube. Okay. Answer is B. Hope you understood this. Yes or no? So again, this was the simple problem only. Steps are long. Many steps are there. 2 marks question. Depends on your practice. If you have practiced well, if your catching power is good, immediately after reading the problem, if you understood how to proceed, you can finish this problem within 3-4 minutes. Because in examination, no need to write like step by step. Write formula directly, put in calculator and get the value. That's simple. Here I am taking 20 minutes for one problem. Why? Because each and every steps I am writing here. My intention is not to write, not to solve the problem only. My intention is like to explain you the uh, all steps. But my point, explanation is my intention, not to get the solution. Hope you understood. Getting solution, that is okay, but at the same time you need to understood the uh, steps for the problems. Okay, so that's the reason I'm taking so much time here for the problem. All right, so now this problem is done. Okay. This is one more problem, GATE 2012. Here, check. The propellant in a single stage sounding rocket occupies 60% of its initial mass. Okay, propellant. Oh, right. We'll write given date. Okay. I must say initial mass for sounding rocket is what? M naught. So what will be the mass of propellant for the this sounding rocket? Okay. So mass for this sounding rocket will be 60% of its initial mass. Okay. So I must say this is 60% of m naught, means 0.6 m naught. That's the mean of it. MP will be 0.6 of m naught. Okay. If all of it is expand it instantaneously at an equivalent exhaust velocity. So they have given equivalent exhaust velocity, which is nothing but 3000 meter per second. What would be the altitude attained by the payload when launched vertically? Okay, anyway, neglect drag and assume acceleration due to gravity. G they have given to us. How much? 9.81 meter per second. So I'll draw the diagram so you will easily understand, because they are asking the uh, altitude. Okay, what will be the altitude attained by the payload? So see, this is the sounding rocket, a small rocket only. Okay, so what will be the altitude for this rocket? Gain. Same rocket only. So from the what distance it has traveled vertically? Okay, h they are asking. That's the problem. Okay, understood. Okay, it is launched vertically in upward direction. So what altitude it would be gaining, that you need to calculate. So how to calculate? I must say, when it is going to launch, that initial velocity is what? U, no doubt about it. Then after certain altitude, it will be gaining the velocity, and that velocity will be the final velocity v. Yes or no? So it is going in vertical direction, so it is v square u square minus 2gh. Yes or no? Simple formula I will use, that's all. What will be the h? Negative sign you ignore, only negative sign will tell you it is going in upward direction, that's all. H will be what? V square by 2g. Yes. What is this final velocity? This final velocity, can you say this is the change of the velocity in rocket, what it is gained? Hmm? Yes. So I must say this is nothing but delta v square divided by 2g. G, sorry. G. Delta v you know how to calculate. What is the delta v? It is called incremental velocity, many words, incremental velocity or change in velocity. Okay, in rocket you can calculate what is delta v based on the given data. You can write the formula. It is ISP G ln m naught divided by mm. Check ISP is given. No, V effective it is given. So yes, we can write ISPG is nothing but V effective or V equivalent. This is the formula only. Okay, you need to remember the formula. So you need to calculate first del V. So equivalent velocity they have given to us ln m naught divided by mm. What is the m naught? You have assumed. What is the mf? Mf is the final mass flow rate. Sorry, mass or mass flow rate, whatever. If m naught you are writing mass, then mf will be mass. If m naught you are writing mass flow rate, initial mass flow rate, then mf will be final mass, brother. It's your choice. Here you have considered it is propellant mass. So we are going to write final mass. So final mass or burnout mass. Burnout mass means initial mass is suppose m naught. So propellant mass if you remove, then you will get final mass or burnout mass. Means after complete burning of the propellant, what is the left part? That is called mf or burnout mass or final mass. I must write m naught minus mp. What is mp? You have written here 60% of initial mass, means 60% of initial mass means 60% of m naught, which is nothing but 0.6 m naught. Right. Okay, so this is nothing but 0.4 m naught. I must calculate this delta v equivalent. How much they have given to us? 3000. M naught mf 3000 1 upon 0.4. How much? Let me calculate this. So 1 divided by 0.4, it's a 2.5, ln 2.5, I'm getting 0.91 multiplied by 3000, that's all. 2744, 2748, 8.8 meter per second. All right. Then we'll calculate the altitudes attained by the payload. Where is the payload? This is the payload. Okay. I must write here altitude attained by payload, or simply you say rocket. I must say payload. So that h, what is the value you got? Delta v square divided by, what is the formula? Here you got, it is 2g. What is the delta v? Just now you have to 2748. 2748.8 square 2 into g they have given, I think 9.81. 9.81. I'll calculate divide by 2 into 9.81. So I'm getting 385132.3 meter. Check the answer. Okay, it is given in kilometer. All right. Convert this in kilometer. Divide by 1000. I'm getting 385.13 kilometer. Check 385.13 kilometer. 385. Directly you are getting option. So what is the correct answer? Your answer is nothing but option D. So hope you all understood this. Okay. Your answer is D. Keep doing hard work. Any doubt if you may get while solving the problems, you write comment on comment box. Definitely I will reply. Keep doing hard work. Thank you. Thank you all.